9, our chapter was complete. Today we will discuss it in digi so that you can easily understand the chapter. Understood? You can understand the concepts. ठीक है? तो हम लोग स्टार्ट करते हैं. आई होप इससे आपको क्लियर हो जाएंगे सारे कॉन्सेप्ट्स. Force. So what is force?
Horrible situation to be stuck in. The man is trying every possible trick to bring his car back on the road. He has finally succeeded. And look what is happening here. This woman is trying to stop the piano from sliding away. Look at both these incidents again. Do you notice anything common between the actions of these two? Both the man and the woman were using force to change the state of motion or rest of an object. The man pulled and pushed the car to set it back in motion, while the woman pushed against the piano to stop it from sliding. A pull or push action on an object is defined as force.
So now the definition is clear to you by understanding these things. See, you have seen the examples, how the man was trying to push the car out, he was trying to pull the car. So these were the examples that were used to demonstrate what is force. Push or pull action on an object is called as force. Now it is clear to you know what is the definition of force. Push or a pull on an object is known as force.
Setting a swing in motion, playing a football match, pulling a heavy load, and the working of machines are all a result of the application of force. Force is an interaction between bodies, or between a body and its environment, causing a pull or push effect or a change in motion. It brings about a change in the state of motion or rest of an object. Force is our constant companion. We use force for the most mundane activities, like opening and closing doors, walking, climbing into a bus, or writing notes. Even getting out of bed requires some amount of force. The result of the force applied on an object depends on the magnitude of the force as well as its direction. Force is hence a vector quantity.
What is force? Force is a vector quantity. And what is vector quantity? Vector quantity is that quantity that has magnitude as well as direction. So result of applied force will depend on its magnitude and direction.
Have you ever noticed that it is often much easier to cycle during sunny days than during windy days? Can you say why? In both both situations there are two forces acting on the bicycle. One is the force applied by the bicyclist on the pedal in order to move the bicycle forward. The other is the force of wind acting in the opposite direction of motion. When there is more than one force acting on the body, the resultant or net force is considered.
So it is clear to you when is resultant force considered? Resultant or net force are the same things. When two forces are acting on body, see, this was the force applied by the ball in the forward direction, but wind blow कर रही है, wind backward direction में blow कर रही है, तो जो force है wind apply करेगी that will be in backward direction. Is it clear to you? तो resultant and or net force will act.
As force is a vector, the resultant or net force also has both magnitude and direction. The bicyclist is pedaling hard to move forward and overcome the force of wind opposing its motion. But what will be the magnitude and direction of this resultant force? When two or more forces are acting on an object and in opposite directions, the resultant or net force will be the difference between these two forces.
So now it's clear to you what is resultant force. Resultant force will be the difference between these two forces.
And the direction of the resultant force will be the same as the greater of the two forces.
Resultant force क्या होगा? दोनों का difference, ठीक है? और resultant force की resultant force की direction क्या होगी? जहाँ पर greater force apply हो रहा है, वो resultant force की definition होगी. Resultant force कब act करता है? When two forces are acting simultaneously. जब दो forces act कर रहे हैं, ठीक है? Resultant force क्या होता है? Resultant force will be the difference between the two forces, ठीक है? Resultant force की direction क्या होगी? Resultant force की direction होगी the direction of the greater force. Is it clear to you what is resultant force? Resultant and the net forces are equal.
When riding a bike on a sunny day, the force of the wind is much less than that exerted by you. However, when riding a bike on a windy day, you will be able to move the bike forward only if you can overcome the force of the wind. The moment you overcome the force of the wind, the resultant force will be in the same direction as you are going. If the two forces acting in opposite directions are equal in magnitude, then the resultant or net force is zero, and the object will remain stationary or in equilibrium. When two or more forces are acting on an object in the same direction, the net force is a sum of all the forces.
See, what happened here? The forces are applied in the same direction. Then the resultant force will be the sum of these two forces.
When an object is stationary,
एक बार आप लोग इस फोर्स को इसको दोबारा देखो. जब
however,
F1 हो
when riding a bike on a windy day, you will be able to move the bike forward only if you can overcome the force of the wind.
क्लियर है? जब विंड का फोर्स ज़्यादा था, then F2 was greater than F1. जब सपोज सनी डे है, सनी डे वाले दिन विंड तो होती नहीं है इतनी ज़्यादा, then force F1 will be greater than force F2. Clear to you?
moment you overcome the force of the wind, the resultant force will be in the same direction as you are going.
तो resultant force कौन सी direction में होगा? Resultant force will be in the direction in which the greater force is applied. Both the directions will be same.
If the two forces acting in opposite directions are equal in magnitude,
See, these forces are equal in magnitude. Resultant force is F1 minus F2. F1 is equal to F2 because the forces are equal. So F1 minus F2 will be 0.
then the resultant or net force is 0 and the object will remain stationary or in equilibrium. When two or more forces are acting on an object in the same direction, the net force is a sum of all the forces. When an object is stationary, are there any forces acting on it? Well, there is the force of gravity, which pulls the object to the center of the earth. Besides gravity, there are other forces, but the forces balance out, and
See, balance out हो रही है forces F1 और F2 और यहाँ पर Fg और F3. Is it clear? ये forces आपस में balance out हो रहे हैं. That is why यहाँ पर इन दोनों का addition 0 लिखा हुआ है.
resultant force is 0. That is how the object remains stationary. Force applied on an object can affect its state in several ways. Let's take a look at some of the effects of force. Force can change the state of motion of an object. It can induce motion in a stationary object. It can change the speed and direction of a moving object. It can bring an object to rest. Force applied on some objects can alter their shape and size.
So now it is clear to you effects of force क्या होते हैं. Force can move a stationary object. एक बॉल पड़ी थी नीचे, बॉय ने किक करा तो स्टेशनरी ऑब्जेक्ट का पोजीशन चेंज हो गया. ठीक है, एक स्टेशनरी ऑब्जेक्ट को मूव कर दिया. चेंज एन ऑब्जेक्ट स्पीड एंड डायरेक्शन ऑफ मोशन. किसी भी ऑब्जेक्ट की स्पीड को भी चेंज कर सकता है और उसकी डायरेक्शन को भी चेंज कर सकता है, उसके मोशन की डायरेक्शन को. ब्रिंग अ मूविंग ऑब्जेक्ट टू रेस्ट. कोई ऑब्जेक्ट मूव कर रहे हैं उसको रेस्ट पर भी ला सकता है. कैन चेंज द शेप एंड साइज ऑफ एन ऑब्जेक्ट. किसी भी ऑब्जेक्ट का साइज और शेप चेंज कर सकता है. सी, यहाँ पर एक बलून था और यू कैन से रबर, जिसको पर्सन ने प्रेस करा तो क्या हो गया, रबर या फिर बलून की क्या होगी, शेप चेंज हो जाएगी और साइज भी चेंज हो जाएगा. What is the definition of force? A push or pull on an object is defined as force, and it is the interaction between bodies or between a body and its environment. Next is resultant force. When two or more forces are acting on an object in opposite directions, resultant force will be difference. In same direction, resultant force will be addition. आपको रिजल्टेंट फोर्स. और इफेक्ट्स हमने ऑलरेडी पढ़ लिए थे, ठीक है। ऑपोजिट डायरेक्शंस में एंड विद इक्वल मैग्नीट्यूड रिजल्टेंट फोर्स विल बी 0, डिफरेंस उनका क्या होगा 0। और इफेक्ट्स, इट कैन मूव अ स्टेशनरी ऑब्जेक्ट, change an object speed and direction of motion, bring a moving object to rest and can change the shape and size of an object.
Sarah and her friends are playing a game of tug of war. Neither side seems to be winning though. Sam has come and joined the opposing team. There, Sam's team has won. How do you think Sam helped his team win? Sam upset the balance of forces between the two teams and tipped it in favor of his team. What do we mean by balanced and unbalanced forces? Let's find out. As you know, a force is a push or a pull. Forces may occur in pairs and can be either balanced or unbalanced.
सी यहाँ से आपको क्लियर हो गया बैलेंस क्या है और अनबैलेंस क्या है। जब अनइक्वल अमाउंट ऑफ फोर्सेस अप्लाई हो
As
रहे
you
हैं,
know, a force is a push or a pull. Forces may occur in pairs and can be either balanced or unbalanced.
क्लियर हो गया। अनबैलेंस और बैलेंस क्या हो गया, जब अनइक्वल अमाउंट्स ऑफ फोर्सेस आर अप्लाइड फ्रॉम बोथ द डायरेक्शंस, देन दैट इज नोन एज अनबैलेंस्ड।
Balanced forces do not cause a change in motion. They are equal in size and opposite in direction. In the tug of war, when there were equal numbers of participants on both sides, the forces applied on both sides were equal and opposite in direction. As a result, the forces were balanced, and the rope stayed pretty much in the same place. Try arm wrestling with a friend who is about as strong as you. What do you think the result will be? Well, at least in the beginning, you will both be pushing as hard as you can, but your arms won't budge. This is an example of balanced push forces. As the push forces exerted on both sides are equal, the resultant force is 0, and there is no change in motion. So what causes a change in motion? Let's consider the tug of war again. When a person was added to a team in the tug of war, the balance of forces was disturbed. The rope moved towards the team with more people. Unbalanced forces cause a motion or a change in motion. In other words, if a force results in motion or a change in motion despite an opposing force, you have an unbalanced force. That's because the forces in this pair are not equal and opposite. Consider a scenario where your family car has broken down and you need to push it to the edge of the road or into a car park. The road is rough. Initially, when you start pushing, the car doesn't move at all. Why doesn't the car move? What force is acting on the car to balance the force you're applying? The car doesn't move initially because of the force acting between the surfaces of the wheels and the road. The force that acts between two surfaces in contact is called the frictional force.
तो frictional force is clear to you?
Thus, frictional force balances out the force you apply to the car. When your friend joins you and both of you push harder, the car starts to move. This happens because the pushing force is bigger than the frictional force. Therefore, the forces are not balanced anymore. To summarize, if the net or total force acting on an object is non-zero or more than zero, the forces are unbalanced. How would you calculate the net force where forces are unbalanced? When unbalanced forces act in opposite directions, their combined force or net force is equal to the difference between them. For example, suppose Sam applied a force of F2 units to the rope. Therefore, the total force exerted by his team would increase to F1 plus F2 units. Net force on the rope would become F1 plus F2 minus F1 units. Thus, if two forces are acting in opposite directions, net force is calculated by subtraction. The net force will act in the direction of the larger force. Forces acting in the same direction combine by addition. Consider the example in which you and your friend pushed the car into the car park. Suppose you and your friend were each applying a force of 1.5 units in pushing the car, and the frictional force between the wheels and the surface of the road was 2 units. Then, net force equals larger force minus smaller force. Net force equals 1.5 plus 1.5 units minus 2 units. Net force equals 1 unit. The value of the net force is greater than 0, hence the forces are unbalanced. How do balanced and unbalanced forces impact a body? When the forces applied on a body balance each other, either the body will rest, or, if it is already moving, it will move with uniform velocity. How does a helicopter remain hovering in the air? The force of gravity pulls it down, but the downward push of the rotating plate in the air balances the weight of the helicopter, keeping it steady in one place. When forces are unbalanced, the extra force causes the object to move if it was at rest. If the object is already moving, the extra force causes the object to speed up or accelerate, or slow down, and or change its direction.
So this is a flow chart to make you clear the concepts. Force, it is explained to you by making 3 categories of it. First is push force. How can B. Push force classified. It can be in balanced and unbalanced forces. Clear to you? And pull forces, it is classified into further two branches, that is balanced and unbalanced forces. बैलेंस्ड फोर्स का जो बैलेंस्ड फोर्सेस क्या होते हैं, जो नेट फोर्स होता है दैट इज 0, और अनबैलेंस्ड क्या होते हैं, जो नेट फोर्स होता है दैट इज नॉट 0. और कैलकुलेशन हम कैसे कर सकते हैं नेट फोर्सेस की? फोर्सेस जो सेम डायरेक्शन में होते हैं वो कंबाइन कर जाते हैं एडिशन से. फोर्सेस इन अपोजिट डायरेक्शन कंबाइन बाय सब्ट्रैक्शन. जो फोर्सेस ऑपोजिट डायरेक्शन में होते हैं उनको सब्ट्रैक्ट कर देते हैं. सी यहाँ पर क्या है, फोर्सेस अपोजिट डायरेक्शन में होंगे जब, तो हम उनको क्या करेंगे, सब्ट्रैक्ट कर देंगे. तो इस तरह से आपको एक फ्लो चार्ट ड्रॉ करके दिखाया गया है सो दैट यू कैन अंडरस्टैंड दिस कॉन्सेप्ट. These are some of the questions. Force can change all except dash of an object, shape, size, nature or velocity. What can be the answer of this? Class, you can note down this question और आप लोग ये करना, फिर उसके बाद हम इसके आंसर्स कल डिस्कस करेंगे. Force can change all except dash of an object. What can be the answer of this? Force can change all except dash of an object. Force can change shape. Force can change size. Force can change nature or force can change velocity. See, what can be the answer of this? What has happened to this? Now see, force can change all except dash of an object. Force क्या change कर सकता है? Force can change shape, force can change size और force can change nature और force can change velocity. आपको इसमें से आंसर बताना है. See, what is the answer of this question? Force can change all except nature of the object. Next question is, when you say that force is not applied, force apply नहीं होता और नहीं हुआ, तो इसका आंसर क्या होगा? चेंज इन मास, चेंज इन डायरेक्शन, चेंज इन शेप, चेंज इन साइज. आपको इसका क्वेश्चन फिल करना है एंड देन यू हैव टू टेल मी द आंसर. क्लास क्या होगा इसका आंसर? ओके, यू हैव टू टेल द आंसर्स ऑफ दीज. एक बार आप लोग दोबारा देखो, वो स्ट्रक हो रहा था बीच में. फोर्स कैन चेंज ऑल एक्सेप्ट डैश ऑफ एन ऑब्जेक्ट. तो व्हाट कैन फोर्स चेंज? दैट इज नेचर. फोर्स कैन चेंज ऑल ऑफ दीज थिंग्स एक्सेप्ट नेचर. नेक्स्ट इज, व्हाट कैन यू से दैट फोर्स इज नॉट अप्लाइड? Change in mass, change in direction, change in shape, change in size. When can you say that force is not applied? आप कब कह सकते हो कि फोर्स अप्लाई नहीं हुआ? what will be the answer of this? Change in mass. When can you say that force is not applied? It is because जब change in mass होगा. Which of the following represents a unit of force in SI system? फोर्स की यूनिट क्या होती है? मास इनटू एक्सेलरेशन. मास का किलोग्राम, एक्सेलरेशन का मीटर पर सेकंड. क्लास आंसर आपने ट्राई करने हैं. ये कर लिया क्वेश्चन नोट. फाइंड द अमाउंट ऑफ फोर्स व्हेन एन अमाउंट ऑफ 1 किलोग्राम प्रोड्यूसेस एन एक्सेलरेशन ऑफ 1 मीटर पर सेकंड. मास है आपके पास 1 किलोग्राम, एक्सेलरेशन है 1 मीटर पर सेकंड. Net force is 0 when the object is at तो क्लास ये कुछ क्वेश्चंस हमने डिस्कस करे थे जो बेसिकली आपको करने थे. आंसर्स मैंने आपको बता दिए. यहाँ पे जो ग्रीन पेन से मार्क हुए हुए हैं, एक बार जूम करके दिखा देती हूँ मैं आपको. तो ये जो आपका फर्स्ट पार्ट था कि फोर्स क्या होता है और बैलेंस्ड और अनबैलेंस्ड फोर्सेस क्या होते हैं, वो कंप्लीट हो गया. कल आगे कंटिन्यू करेंगे इसी के साथ. ओके, थैंक यू.